Okay, part C, find the distance that the camera travelled during the first hour of motion. Okay, so this is distance along a curve, and I'm going to use the parametric equation version, which will be the distance equals the integral from the start time to the end time of the square root of dx dt squared plus dy dt squared dt. So in this particular case, it's going to be distance will equal the integral from 0 to 1, because we're doing it for the first hour. The square root of, I'm going to have 2t on top of 1 plus t squared dt squared plus d dt of 2, 1 minus t squared on top of 1 plus t squared dt. Now that's just putting on the calculator. It's worth 2 marks. Write this out and you'll get 1 mark. Write the answer, you get the 2nd mark. Okay, so I've got the integral from 0 to 1. I've got a big square root. Inside the square root, I've got the derivative of the x squared plus the derivative of the y component, all squared, all under the square root. When I press x here, I get an answer of 2.42. So that's 2.42 to 2 decimal places. Get into the habit of writing 2.422, therefore roughly equals 2.42, the distance, kilometres in this particular case. Okay, in the second part of the question it says the maximum speed of the camera during its motion. So what I'd like to do is I'd like to find the velocity of t, and then I'm going to use the maximum speed. Find the speed, and then find an expression for it, and then do the use Fmax. So I know that my velocity will be the square root of the inside here, because this will be the derivative of displacement, which will be position. So if I take my inside of this and also take the square root, that should be an expression for the speed at any particular time. And if I take that and if I go interactive calculation Fmax between 0 and 3, that's going to give you an expression of about t. Always a bit of a problem when you use the different variable. And I've now got a maximum value of 2.73 kilometres per hour as being the maximum. And if you wanted to know what time that was at time 0.4969, 0.50. Didn't ask for the time though, it's just asking for the maximum. Now, the velocity would be the derivative of position, which is why I was able just to take this square root and put that in there.